Welcome, dear ladies and gentlemen. Firstly, please accept my appreciations for participating to my presentation. The topic of my presentation is the manufacturing and qualification methodology of the aviation grade parts. Before I start to my presentation, now I would like to give a brief information about myself. I am assistant professor in the İstanbul Gelişim University Aeronautical Engineering Faculty. I am also head of the aircraft, airframe, and engine department. I'm pilot and aviator since 1994. Now, I would like to start my presentation. The manufacturing and qualification methodology of the aviation-grade parts. The aviation industry is a well-framed and well-regulated industry that is governed by the International Civil Aviation Organization under the United Nations. There are some regional authority bodies, such as the Federal Aviation Administration (FAA), originated in the USA, and European Aviation Safety Agency (EASA), originated in Europe. Additionally, every country has its own local airworthiness authority to ensure aviation safety. These local airworthiness authorities are called as Country Airworthiness Authority (CAA). For ensuring aviation safety, both international authorities and local authorities put stiff regulations to define manufacturing, maintenance, and training activities. These regulations include certification and production approval, airworthiness of aircraft, certification of aircraft personnel, facility, and other safety-related matters. For approval of a company, some audits are executed by authorities. As these audits are satisfactorily completed, the candidate company may gain the privilege of manufacturing a part on the aircraft. A part on the aircraft may be called as aviation-grade part, airworthy part, airborne part, ready-to-take-off part, flight-ready part, flight-grade part, and aviation-grade part. After initial approval, it's a must for the manufacturer company to pass the periodic continuing audits successfully. As it was mentioned before, any major failure may result in the interruption of the mass production line. For example, after two fatal accidents of Boeing 737 MAX aircrafts, killing 346 people in total, EASA, FAA, and many countries' airworthiness authorities stopped all the operations of Boeing 737 MAX, and many aircraft have been weighted as aircraft on the ground status with the force of authorities. The investigation reports showed that the problem was originated from the Maneuvering Characteristic Augmentation System (MCAS), which was newly designed and implemented to Boeing 737 MAX aircraft against excessive angle of attack (AOA) trend that causes the vertical instability. ICAO makes safety studies and expresses some warnings that the new technology and new concepts may impact aviation safety negatively unless they are not matured enough. There are many manufacturing techniques, while 5 of them are the most commonly used ones. These are joining technologies. The parts are produced with the joining techniques such as welding, riveting, etc. A welded surface of a vehicle can be a good example of this technology. Cutting technologies. The parts are divided into smaller parts with the saw machines, water jet machines, etc. A cut aircraft composite skin part can be an example of this technique. Chip away technologies. Milling machine, turning machine, lathe, drills are the machines used for chip away techniques. A bulkhead that is manufactured with a 5-axis milling machine can be an example for a chip away manufacturing technique. Form changing technologies. Sheet metal forming, forging, or casting processes are used for form changing manufacturing techniques. In this technique, there is no chip, so the raw materials weight and the final product's weight are almost the same. Additive manufacturing technologies. This technique is a newly developed technology that has been used for almost 3 decades. In this technology, parts are produced layer by layer. It can be considered of as the opposite of the chip away technique. Additive manufacturing is a quite new technology that is defined as a disruptive one. With its novel structure, the additive manufacturing changed the paradigm of production techniques. It is based on the conversion of three-dimensional geometries into simple two-dimensional layers. Hence, it provides opportunities for the production of complex parts. The open literature documents give clues that additive manufacturing is taking place of conventional subtractive techniques. For manufacturing methodology, the chain of part, component, assembly, and top assembly relation should be understood. A standard commercial aircraft consists of 3 or 4 million parts depending on its type. It should be underlined that the freighter aircraft will have significantly fewer parts than the fuel passenger versions. The components are made of parts and the assemblies are made of components. The aircraft itself is the top assembly, which consists of structural parts, for example longeron, spar, rib, bulkhead, etc. Standard parts, for instance MS fasteners, NAS fasteners, screws, nuts, self-locking nut plates, etc. Consumables such as tires, fluids such as hydraulic and hydrogen, etc. Commercial off-the-shelf codes, for example actuators, CVR, FDR, upholstery items, yoke, etc. Loose items such as plugs and software, etc. Now, let's go details with an example. Our example is landing gear. In a landing gear system, the shock strut and other load-carrying parts are the structural parts. The screws, nuts, and other fasteners are the standard parts used on the landing gear. The hydraulic fluid that transfers the force is a consumable. The actuators and customized switches are the coach parts. And finally, the plugs on the pipes and the hoses are the loose items. From the manufacturing pyramid point of view, the piston and piston pins are the parts, actuators are the sub-assembly, and the landing gear system is an assembly. Finally, the aircraft is the top assembly. From bottom to the top, the manufacturing of an aviation-grade part has its own unique flow. The parts are at the bottom, while the top assembly is the aircraft itself, as it was mentioned previously. It is noteworthy that there are some similarities between common manufacturing lines and airborne part manufacturing lines in terms of the plant layout and lean manufacturing line. Before providing information about aviation-grade part manufacturing, the manufacturing pyramid of the top assembly is an essential issue. Basically, the life cycle of a part is divided into 6 phases. These phases are design, production, development, operation, follow-on support, and disposal. In the aviation industry, for a company that designs the aircraft part, there are some requirements that must be met. The certification process is called as Design Organization Approval, abbreviated as DOA. Similarly, the Airworthiness Authority makes audits for certification for manufacturing. This certification process is called as Product Organization Approval, abbreviated as POA. The Airworthiness Authority executes the system audits and inspections, whether the company has the capability of designing the aviation-grade part. To understand this, Airworthiness Authority makes detailed inspections on organizational structure, working environment, accreditation of management personnel, control of tool and equipment, certificate release staff validation, facility requirements, protection of design and manufacturing data. As a result, a company that is candidate for designing and manufacturing aviation-grade parts should follow the stiff regulations of national and international airworthiness authorities. Dear ladies and gentlemen, thank you for your valuable time and patience. My contact information is on the screen. Please do not hesitate to ask questions. I wish you wonderful days. Thank you.